time to get into quadrilaterals. But before we can get really in depth into our quadrilaterals, we need some base information about our polygons. So the first thing we're going to talk about are the angles of our polygons. We're going to talk about interior and exterior, for the most part interior. So one term here, a diagonal. So if I have a reference to the word diagonal, I'm talking about a segment that connects any two non-consecutive vertices. So if I look at A, the non-consecutive vertices to A would be C and D. So I could connect from A to D, or I could connect from A to C, and that would be a diagonal drawn in. Okay, so if I refer to diagonals, that's what that means. So let's use that information. I'm going to come up with a formula that we can use for the sum of our angle measures, our interior angle measures in our different polygons. So for the first thing, I'm just going to look at the triangle. Okay, I have a quadrilateral, pentagon, and hexagon up here with diagonals drawn in. Let's take a look at this. Let's look at our triangle. Well, triangle we know has three sides, and it has just one triangle, right? That's why they call it a triangle. So if I think about the measures of the angles added together, the sum of the interior measures, it's 180 degrees, right? So for a triangle, all three angles, 1, 2, 3, they add up to 180 degrees. Okay, hopefully we know this by now. Well, if I broke the rest of my shapes into triangles, I know that triangles add up to 180, right? So if I look at my quadrilateral, if I draw on a diagonal, I now have two triangles. So I know that this left triangle here, those three angles would add up to 180. And this right triangle here, these three angles would add up to 180 for a total of how many degrees? 360 degrees. So all the angles in my quadrilateral, if I took out that diagonal, if I added up all four of these angles, they're not congruent, but they'd add up to 360 because I have two triangles in there. Okay, so really I'm taking 2 times 180, right? 2 times 180 because I have two triangles. Well, for a pentagon, when it has 5 sides, now there's 3 triangles, so I'm taking 3 times 180. And for a hexagon, it looks like it makes 4 triangles. Kind of hard to see, but triangle, 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 triangle. Okay, we got 4 triangles in my hexagon. And we're multiplying that by 180. So if you look at all these angle measures, the quadrilaterals added up to 360, right? 2 times 180. Pentagons added up to 540 because we took 3 times 180. So really we're just taking 180 times the number of triangles that's inside, right? Or if I think about it, to get the number of triangles, I'm just taking the number of sides minus 2 each time, aren't I? Minus 2 to get the number of triangles. And then we're taking that number of triangles times 180. So if I came up with a formula, if I just said we have n sides. Okay, so let's just say we have an n-gon. Has an n amount of sides, right? It's got the n amount of sides. Well, we just found out the number of triangles that exist in that polygon would be n minus 2, right? Because I'm just subtracting by 2 to figure out how many triangles. And we're taking that amount of triangles times 180 to figure out our total sum of the measures. So right here, if I had any polygon, let's just try it for one that I have up here. So I know that a hexagon adds up to 720. So I'm saying this formula, the sum of the measures of the interior angles, the sum of the interior angles, I'm going to call it S. If I take 180 times n minus 2, I should get the total sum. Well, let's try the hexagon. So there are 6 sides, so I'm going to plug in 6 for n and see what happens. So 6 minus 2 is 4, and 4 times 180 gives me 720. Is that what I was looking for? 720, there we go. So 720 degrees for a hexagon. So I could use that for any type of polygon. I could use it for a 24-sided polygon. I just plug in 24 for n. So I just came up with that formula there. N minus 2 times 180. So let's apply that. So find the sum of the measures of the interior angles. So sum of the interior angles, that's just my formula. Or it doesn't matter. I could write it the other way too. 180 times n minus 2. Whatever. However you want to think of it as. Because it's made up of triangles, right? How many triangles exist in that polygon? Well, what type of polygon do I have? A nonagon. So we might have to think back. How many sides is a nonagon? Well, that is a 9-sided polygon, right? 9-sided. So all I got to do is just plug it into my formula here. So 180 times 9 minus 2. So it's just the number of sides minus 2, and we're going to take that times 180. So really we're taking 180 times 7, which gives us 1260 degrees. And just be careful, always go back and reread. It says find the sum of the measures, sum of the measures. So that's my answer, 1260. Sometimes it asks for just one angle or a specific angle, but if it's for the sum, I can just apply that formula and I don't need to do anything else. Right, so for example here, now we're not just finding the sum. It says find the measure of each interior angle of parallelogram RSTU. So I want to find all the angle measures. I want to know what angle S is. I want to know what angle R is. I want to know what angle T is. And I want to know what angle U is. Okay, well, it looks like S and U are the same. Right, they're both 11x plus 4. I can't just set those equal, right? This wouldn't make any sense. Because my x's would cancel each other and 4 equals 4. So we don't want to do that. We're not going to set them equal. So what else do I know? Well, I have a quadrilateral, right? A parallelogram is 4 sides. It's quadrilateral. Do I know how much all 4 of these angles add up to? All 4 of these angles? Well, if we think back, you might have to apply your formula if you can't remember. But I can figure out what they all add up to. 180 times the number of sides minus 2. Which in this case is 360. And that one's kind of an easy one to remember. So it's just made up of 2 triangles, right? 180 and 180. So for 360. So I can use that. So I'm saying that all 4 of these angles add up to 360. So I can just add them all up. That plus that plus that plus that equals 360. Or if I think about it, I have 2 of these 11x plus 4s. So I can just take it times 2. And I'm adding that to 2 of my 5x's. And they total 360. Or just add them all up if you don't like that multiplying part. So really here I have 22x plus 8 plus, well, 2 times 5x is 10x. It's just the 2 times 5 equals 360. And now let's simplify. So it looks like I have a 32x when I combine my x's. Plus 8 equals 360. So subtract your 8. So you got 32x equals 352. And the last step, divide by 32. And when you do that, x is going to equal 11. So x equals 11. Is that our answer, though? Is that what I'm looking for? No, it wants all the angle measures, doesn't it? So I got to go and plug this guy back in to solve for these angles. So 5 times 11, I can get that one for angle R and angle T. 5 times 11 here, which gives us 55 degrees. So I know those two are 55 degrees. And for the other one, we have 11 times x, which is 11 plus 4, which equals, well, 121 plus 4, which is 125 degrees. And there we go. And if I really wanted to check, I could add up all 4 of these guys and see if they add up to 360, which they should. Okay, but there's my answers. 125 and 55 degrees for all 4 of those angles. So just be careful on what you're trying to find. Next thing, it says a mall is designed so that 5 walkways meet at a food court that is in the shape of a regular pentagon. And I have that here. So what does a regular pentagon mean again? It means that all sides and all angles are congruent, right? So I know that all these angles are the exact same thing. Find the measure of one of the interior angles of a pentagon. So I just want to know what one of these angle measures is. Well, we don't know how to do that. The only thing we know how to do is to find the sum of the angle measures, right? I can find the sum by taking 180 times the number of sides minus 2. Well, if I know the sum, to find one of them, can't I just divide by the number of sides? After you find the sum, divide by number of sides, which in this case is n, right? We're using n for the number of sides. So after I find my sum, so let's go ahead and do that. 180, and it's 5-sided, it's a pentagon. So this is really 3 180 times 3 gives us 540. So that's the sum of all 5 angles. Well, I just want one of the angles, so we divide by how many angles there are, which would give us 108 degrees. So just be careful. In this case, I just wanted one of the sides. So you just got to pay attention to what they're asking for. Remember, our formula just finds the sum of all the angles. How about this? The measure of an interior angle of a regular polygon is 150. Find the number of sides in the polygon. So what would I do here? Now it told me what one of the angles is. So how can I come up with the number of sides? Well, if you think about this last problem, what did we take? To find one angle measure, we took 180 times n minus 2, and then we divided by the number of sides. Right? And that gave us what that interior angle measure was. So I could come up with a formula for this. To find one interior angle of a regular polygon, in this case it's 150, what do you take? You take 180 times the number of sides minus 2, and then you divide it by the number of sides. Isn't that what we did? So I could trial and error this, but it might take you a while. So if I use my formula, if I think about, here's the sum of all the angle measures, divide by how many sides there are, it gives me how much one angle measure is. So if I create this equation, I could actually solve for n. Okay, so I don't want a variable in the denominator, so to get this n out of the denominator, I got to multiply by an n. That's how you get something out of a denominator. And whatever you do to one side, you got to do to the other side. So these n's cancel, and over here I have 150n equals, I'm going to distribute that 180. 180 n minus 360. Now I have an equation I can solve, don't I? All right, it's nice and easy now. I just subtract my 180n over 180n, and we're left with negative 30n equals negative 360. And we can divide by negative 30. And n gives us positive 12. So that would be for a dodecagon, right? A 12-sided shape. What about for exterior angles? What if I extended each side? I have exterior angles, okay, and all these sides have to be going the same way. If I added up all these exterior angles, if I added up angle 1, 2, 3, 4, 5, and 6, I get 360. So all these angles add up to 360 degrees. And that works for any convex polygon. Any convex polygon, that'll work. So for example here, if I want to find what x is, when this says find the value of x and the measure of each angle, so I got to find both of these. So find x first and then the measure of each. So I know these add up to 360. That's just my one property for exterior angles of polygons. So I can say, I'm going to put all my x's first. So 6x plus 9x plus 2x plus 139 equals 360. And then I just go through the math. So I add all my x's and I get 17x. And I'm going to subtract my 139 right away. And in this case, I get 221. And then we'll divide by 17 on both sides. And so x is going to give us 13. And what we need to do is plug it back in because we need to know all the angle measures. So I got to plug 13 in for all of these guys to find the angle measures. And I can just do it right by here. So let's do the bottom one. 2 times 13. So I know this angle measure is 26 degrees. Up top, 6 times 13 gives me 78 degrees. And 9 times 13 gives me 117 degrees. So there's my answer. X equals 16, and then all these angle measures. And they should add up to 360. Okay, so a little bit about the angles of polygons.